All right, welcome back, College Algebra. Today we're going to be looking at sum and difference identities. All right, you use these identities when you're given a radian that's not on the unit circle. Okay, so what I'm going to do today is I'm going to do the first three, well actually, I'm going to do the left side column. Then I want you to pause this, and I'll tell you when, and I want you to try the other ones, and then I'll continue the video on, and I'll show you the other three as well, just so you can see the examples, and hopefully you've done them on your own, and you can see if you're right. Okay, so these are the four identities for sine and cosine. So you got two for sine, so there's plus or minus for sine, there's plus or minus for cosine. All right, and what you're going to do is you're going to use this idea if you're given a radian for a problem that's not on the unit circle. So in question number 1, we see that it's 5 pi over 12. Okay, so the question is, how do we make this into a radian that we do know that's on the unit circle? All right, and what we're going to do for this is we're going to either find two numbers that can be added or subtracted to give you 5 over 12, and then also be able to be reduced. Because the reducing part is a key piece of this that many students often, get wrong, and then it doesn't work. Okay, for example, let's say I wanted to take 5 over 12, and I said, okay, well, I know two numbers that can give you 5 over 12. I'll do 4 over 12 plus 1 over 12. Okay, so now here's the thing. 4 over 12 can be reduced to be 1 over 3. Okay, but 1 over 12 can't be reduced, so that doesn't help us. Okay, so when you do these problems, the two numbers you come up with have to give you the number on top, or they have to add up to give you the number that you started with, but they also have to be reduced. So you see here we give you a clue. We have 3 pi over 12 plus 2 pi over 12. Well, these can both be reduced. So we have pi over 4, and we have plus pi over 6, because we reduced both of them. Okay, so now, because we added them, we're going to look at the sine, since we're doing sine, and we're adding. This is going to be the identity that we're going to use. We're going to use the sine, and then the one's got plus. So how you do this, this is going to be your x term, this is going to be your y term. It really doesn't make a difference, it's just whatever order you did it in. Okay, so we have sine of x, so sine of going to be pi over 4. All right, we're going to do the cosine of the y value, which is pi over 6. All right, plus the cosine of x, which is going to be cosine of pi over 4. And then the sine of y, which is going to be the sine of pi over 6. Okay, so what you're going to do now is you're going to need your unit circle. You're going to find out what these values are. So if we look at pi over 4 and find the sine value, that's going to be root 2 over 2. All right, for the cosine of x, for the cosine of pi over 6, at pi over 6, the x value is going to be root 3 over 2. Put these both in parentheses so remember what we're doing. Plus, all right, the cosine of pi over 4 is going to be root 2 over 2. And the sine of pi over 6 is going to be 1/2. Okay. So next, all we do is we multiply those numbers together. So the root 2 times root 3 is root 6. 2 times 2 is 4. All right, root 2 times 1 is root 2. And 2 times 2 is 4. Now you'll see here, we have two fractions with a common denominator. We can just combine those two fractions. All right, all you're going to do is you're going to show that you're adding the numerators on top, and the denominators won't change because denominators don't change when you're adding fractions, if they are the same. So we have square root of 6 plus the square root of 2 all over 4. And this is your answer. Okay? All right, so again, as kind of a recap, you're trying to find two numbers that either add or subtract to give you the number you started with. In this case, it would be 5 pi over 12. All right. When you do that, you have to make sure that both numbers are reducible so that they can be found on the unit circle. If they're not, then it's not going to work. Okay, and then you put them into the formula, find out the values from the unit circle, and then start doing just the math of multiplying and then adding the fractions. Okay? All right, we're going to go down and do number 3. So I'm going to show you some of the difficulties we have in doing these problems. All right, for example, let's say you want to do 6 over 12 plus 1 over 12. Okay, well, that does give you 7, And 6 over 12 does reduce, but 1 over 12 does not, so that doesn't work. Okay, so let's try something else. Well, let's do 5 plus 2. Okay, well, 2 over 12 does reduce, but 5 over 12 does not. So you have to pick values that are going to work for your number. All right, we're going to pick 4 pi over 12 plus 3 pi over 12. Okay, these will both reduce. So we will have pi over 3 plus pi over 4. Okay, so those are the values that we're going to use. Again, we're using sine, and it's going to be the plus. So we can go back up to the formula. Again, the formulas are all going to give you at the top of the sheet. Okay, so we're going to use the sine formula. That's going to be adding. So we're going to do sine of x, which is pi over 3. Oops, hold on. Nope. There we go. Sorry about that. All right, so we have pi over 3. We have cosine of y, which is going to be cosine of pi over 4, plus cosine of x, which is going to be cosine of pi over 3, and then sine of y, which is going to be sine of pi over 4. Okay, so now that we have our equation written out, all we have to do is use the unit circle to find out what those values are. So sine is y at pi over 3 is going to be root 3 over 2. All right. Cosine at pi over 4 is going to be root 2 over 2. It's the x term. Plus cosine at pi over 3 is going to be 1/2. Oh, not 1/3. All right, and sine of pi over 4 is going to be root 2 over 2. So again, we multiply out the fractions. So root 3 times root 2 is going to be root 6 over 4. And then 1 times root 2 is going to be root 2 over 4. We add those together, we're going to get root 6 plus root 2 all over a common denominator 4. Okay, now some obvious stuff. Okay, notice the two numbers, the two answers we got were the same. Okay, this, you're going to see a lot of the same things look similar or the same because when we look at the unit circle, we're only dealing with really like 3 to 4 numbers or 3 to 5 numbers. We got root 3 over 2, 1/2, root 2 over 2. We got 1s and 0s. That's all the unit circle values are. Okay, so a lot of times your answer is going to look the same. So again, we're looking for the work, not necessarily the answer, to help us out. Okay. All right, now I'm going to try number 5. Number 5, okay, we're dealing with cosine, and is x minus pi over 2. And now you're thinking, well, I can't figure out what x, well, I don't know what x is. Well, you're right, you don't know what x is. So don't actually think about it. Just if we don't know what x is, you're going to put these values into one of the formulas on its own and see what you come up with. Okay, so we don't have to find out what adds or subtracts to x minus pi over 2 because x minus pi over 2 is what we're going to subtract. So the x value is the x. The pi over 2 is going to be the y value. And we're going to use the cosine. And since it's minus, we're going to use the cosine minus. Okay, so if we look up at the top, I'm using this formula right here. Cosine x minus y. All right, so here's how it works. So we're going to do cosine of x, which is going to be the cosine of x, because x is x. All right, times the cosine of y, which is pi over 2. Now notice we're not putting minus pi over 2 because the minus sign, this minus sign just tells us which formula to use. Okay, so it's not a negative pi over 2, it's minus pi over 2, and the minus tells us that we're using this formula. Okay, we continue on with the formula. We're going to put plus, then it is sine of x, and x is x, and then the sine of y, so it's the sine of pi over 2. Okay, so the only two values we need to find in this particular problem is the cosine of pi over 2 and the sine of pi over 2, because the cosine of x and the sine of x don't change. All right, so the cosine of pi over 2 is going to be 0, and the cosine of x just stays the way it is. All right, the sine of x again stays the way it is, but the sine of pi over 2 is going to be 1. So cosine of x times 0 is nothing. Those go away because anything times 0 is 0. And sine of x times 1 is whatever is left over, sine of x, and that becomes your answer. Okay, so now what I'd like you to do is pause the video for a second, right, and then try the other three problems, 2 through 6, and then see how they work out. Okay, so please pause the video and try the problems. Okay, hopefully you paused the video and tried the problems, but we're back. All right, so this is hopefully you did these problems and we can see how they work out. All right, for number 2, we've already given you the options. You want to get negative pi over 12. Okay, again, you can do a bunch of different things. You could have done 6 minus 7. Okay, the problem is 6 over 12 reduces, but 7 over 12 does not. You could have done 8 minus 9 over 12. This would have worked because 8 over 12 reduces and so does 9 over 12. You could have done 3 minus 4. You could have tried 5 minus 6. That wouldn't work because 5 over 12 doesn't reduce. For this particular problem, we've already given you the options of which ones we're going to use. So it's going to be cosine. This is minus, so we're going to use the same formula we just saw. Okay, in question number 5, right? Yeah, 5. So here we go. This is the x term. This is the y term. So we have the cosine. Oh, sorry. You know what? Let's back up for a second. Let's reduce these values so it makes a little bit more sense when we're doing this. Okay, so 3 pi over 12 is going to be pi over 4. Minus 4 pi over 12 is going to be pi over 3. All right, this is the x, this is the y. So now we can go put those into our formula. So we have the cosine of pi over 4 times the cosine of pi over 3 plus the sine of pi over 4 times the sine of pi over 3. Again, remembering that this negative sign is not going to make the pi over 3 negative. It just tells you which formula to use. It's part of the formula. Okay, so looking at our unit circle, the cosine of pi over 4 is going to be root 2 over 2. Okay, the cosine of pi over 3 is going to be 1/2. Plus the sine of pi over 4 is going to be root 2 over 2. All right, the sine of pi over 3 is going to be root 3 over 2. Okay, so again, we're multiplying across. We're going to get root 2 over 4 plus root 6 over 4. Then we can combine those two fractions because they have a common denominator to give you root 2 plus root 6 all over a common denominator of 4. I don't know if you guys can hear the background music, but somehow upstairs my daughter's blasting Frozen soundtracks. All right, number 4 here. We have 11 pi over 12. Okay, so again, we have to find values that can add up to be, add or subtract to be 11. Okay, so first thing that popped in my head was 5 and 6, but 5 doesn't reduce with 12, so that wouldn't work. Okay, so let's see here. How about 8 plus 3. So we have 8 pi over 12 plus 3 pi over 12. And that would work because they're both reducible. So for the first one, we're going to have 8 over 12 gets reduced by 4. So we're going to get 2 pi over 3 plus pi over 4. Okay. So we go back up to our formulas. We can see we're going to use, since we're adding in this cosine, we're going to use this formula, cosine x plus y. All right, so we're going to use that formula. So we're going to have cosine of x, cosine of 2 pi over 3. That's the x term. All right, then we're going to have the cosine of y, which is pi over 4. All right, the formula says minus. Then we have sine of 2 pi over 3 times the sine of pi over 4. Okay, again, we look at our unit circle, find out what these values are. So at 2 pi over 3, the x term for cosine is going to be negative 1/2. All right, for cosine of pi over 4, we're going to look at root 2 over 2 minus the sine of 2 pi over 3 is going to be root 3 over 2. And the sine of pi over 4 is going to be root 2 over 2. Okay, multiply this out. We're going to get negative root 2 over 2, or sorry, negative root 2 over 4, sorry, got to multiply the bottoms, minus root 6 over 4. So our answer is going to be negative root 2 minus root 6 all over 4. That's your answer for question number 4. All right, and lastly, the ones that don't have to be added or subtracted because they already are what they are going to be because, well, you don't have a radian you're looking at. You have two different pieces that can't be combined, okay? So we're dealing with sine and plus. So again, you're going to use the formula that we first started with in question number 1. So this is going to be the x term, this is going to be the y term. So we have sine of sine of pi, my apologies. All right, times the cosine of x plus the cosine of pi times the sine of x. Okay, so again, we're looking at a unit circle, but we're going to have to find two of them because the cosine and sine of x, well, they just are cosine and sine of x. So sine of pi, if we look at this, the pi on the unit circle, the y value is 0 times cosine of x plus the cosine of pi is negative 1 times the sine of x. All right, this side goes away because 0 times cosine is nothing, and you're left with negative sine of x. Okay. And there we go. All right, that's it.